Now minus 2c plus 5. Less than 3 over minus 2c plus 5 again, wow, greater than or equal 11. Remember, we are doing compound inequality. What is that? It's a two inequality. 1, 2. Separated by conjunction, maybe and or maybe or. And you need to remember that or is union. Union. And no, and is intersection. Pero or, que es, no, that problem is union. Union means que es put together without repetition. Entonces you, no problema. You separate the problem into pieces. You solve the first inequality, solve the second, and put together numerically or graphically and on the number line. It's doing. Entonces minus 2c, bring down, less than 3, minus 5. I move 5 to the right hand side with the opposite sign, get negative. Minus 2c, less than minus 2, divided by negative 2 both sides, because I need c alone, positive. And don't forget, when you divide it by a negative number, you need to reverse it, the inequality sign. Negative 2 divided by negative 2 is 1. Boom. This is my first piece of solution. The second piece is similar to z greater than or equal 11 minus 5. Minus 2z greater than or equal, this is 6. Divided by negative 2 again. C alone is, this is negative 3. And this is less than or equal to. Equal stays the same, however, greater than is changed to less than, or less than changed to greater than. So now, see, we have this information. Okay. Let's do in the number line. Normally, this is classical idea. The inequality compound ending graphically, because it's the easy way, in my opinion, to understand the connection between these solutions. In this case, union, and union is put together without repetition. This is my ordinary number line. This is infinity positive, this is infinity negative, 0 in the middle, 1 here, and minus 3 is 1, 2, 3, minus 3. Okay, let me represent that part. That part is x greater than 1. It's from 1 to the right, and of course, do not include 1. A symbolic way to indicate this idea, no equal parentheses. However, the second piece, let me use another color, is this piece. It's minus 3 here, but to the left. And include 3. Of course, include 3 because it's equal to include minus 3, sorry. So the symbolic way to indicate this idea is bracket. Okay, so now the answer, you can express it like that. They want this notation, okay, no problem. Open curly bracket, you put a name of the variable z, such that, and you put this on this condition, okay? This condition is z less than or equal minus 3 or z greater than 1. Another way to visualize or represent this idea is you put an interval notation. It's the most popular. Is the red piece is from negative infinity, comma negative 3 bracket, union, parenthesis 1 comma infinity. Okay, you need to be aware to represent it. Remember, this is graphically set builder notation and interval notation. Let me try to see what is the option que matching good here. I suppose que es A, no? I suppose que es A. Any question? No? Super clear?
Yep.
Okay. Let me know see I can erase the board or no. I can? Yes or no?
Yep.
Yes. Claudia dice yes. Ok, Claudia. Entonces 18. 18 is similar. It's the compound inequality again. Minus 3x plus 3 greater than 0 or, again, or, remember, or and, minus 3x plus 3 less than or equal to 12. Okay. I try. I manipulate the first inequality, minus 3x greater than minus 3. I move the 3 to the right hand side with the opposite sign. Divided by minus 3. Be careful when you divide inequality by negative number, you reverse it. This is x only. This is now less than 1. Okay, and the second is minus 3 is less than or equal to 12 minus 3. Okay, 9. And 9 positive. When you divide by negative 3, because the goal, remember, is isolate the x positive, no negative. I don't care negative x, I care positive x. So we have x is greater than or equal minus 3. Okay. It's similar, but this example brings me new situation. Pay attention. This is my final step in which you put together both statements. Okay, this is 0, this is 1, and this is minus 3. Minus 1, 2, 3. Okay, this guy is to the right. Let me try to do it this way, because to avoid to see more clear when the interval overlap. Okay, it's from negative 3 to positive infinity, so to the right in this direction. Of course, include minus 3 inside because it's equal. And the second, let me using another color, is less than 1. So less than 1 is from 1, but in this case to the left in this direction. And of course, no including 1. And the way to indicate this is using parentheses. But in this case, or. Be careful with the or. Okay? Or sometimes is confusing. Or is union. As you put together without repetition the interval red and the interval green, you see that this union together represent all real numbers. Because when you take the red, you take the number from negative 3 to positive infinity. And when you take the green, you take the number from negative infinity to 1. Es obvio que the intersection is in between negative 3 and positive 1, but I don't care intersection. I care union because the keyword of the connection to inequalities or. Entonces, union. Entonces, es obvio que the solution is all real number. How you write that? Well, curly bracket, x such that x is all real number. The way que personally I like so much is from negative infinity to positive infinity. Do you understand this or no? Okay. Again. Let me use another color. See, I highlight blue maybe. The first solution gets the red one. I highlight in blue now. And the second solution gets the green. I highlight again in blue. And together represent all real numbers. Make sense? Make sense or no?
If it's the entire line.
Exactly. Exactly, entire line. Entire line. Different situation happen si I change this conjunction by the and. Oh, no, es different. Si es and, entonces es intersection. And es obvio que the intersection es that part. The part, the common part. The part que both interval share. But no, in this case, no share. Es union, put together without repetition. Cool? Cool? Cool or
Yes.
no? Okay.
Yes.
Okay, so let's move on to the next page, que es the last example of the compound inequality. I promise in the review packet, I go again over this, but so far no. Okay, cool. Let me copy. It's 2x plus 3, 2x plus 3, less than or equal negative 9. Or, again, or 2x plus 3, less than or equal negative 1. Okay. You don't worry too much. You solve it separately, both inequality, and finally we connect. Entonces, 2x less than or equal to negative 9 minus 3. I'm moving 3 to the right hand side. Opposite sign, negative. 2x less than or equal minus 12 divided by 2. Pero 2 is positive, entonces it doesn't change this sign. It's less than or equal minus 6. Likewise, here, 2x less than or equal negative 1 minus 3. 2x is less than or equal minus 4. Divided by 2 positive. Nice. I like positive. When you divide by positive, the inequality sign stays the same. Less than or equal negative 2. Now I am ready to do the last step. It's the most important. Is put together this statement in one number line. Okay. Infinity positive, infinity negative, 0 in the middle, negative 2 is here, negative 3, 4, 5, 6, negative 6. Okay, now let's do it. That part is less than negative 6. It's to the left. Less than. And include, of course, bracket here. And the second part, let me change the color, maybe red, is again to the left. But is, let me try to do not exactly here, sino here. I highlight no on the line to see more clear. Is continue forever in that direction and here bracket again. Okay, so now I try to find the or in between this and this, or. Entonces, look like a little bit complicated because the problem is that the interval blue is totally inside the interval red. And when you put together, so the union is obvious, in my opinion, no? Que is the red, because the red is bigger, right? And this is subset, so it's inside, totally inside. Therefore, this is equivalent to say x such that this is the typical format to write the final answer, no? Is x less than or equal minus 2 only, no? Because the blue is completely inside the red. Now the union is the red. Makes sense or no? No?
Yes.
Yes. Okay, this is a typical example. Okay, I would like you understand very well because it's the typical example you see in the test. So some particular situations in which you need to understand very well the concept of the or and the concept of the and. Si I change this conjunction by the and, it's obvious that the answer changed totally. It's not the red, it's the blue, because the common element between red and blue is the blue. And see, you put the union, no, the union is the red, because it's the bigger. Makes sense, right? Guys, let me know if you understand this or not. Because sometimes it's a little bit confusing this. Clear or no?
I had a question. When do you know to go right or left? Oh, never mind, never mind.
Yeah.
I
It's the
just
left.
never
It's the
mind.
left. Miss, it's the left.
Yeah.
Because this is less than, no? Entonces, the mnemonic device, to understand this, you understand like an arrow. You point to the left. Make sense?
Yeah, thank you.
Okay, guys, so let's change to another problem, que the system of equation. Linear system of equation is, well, a little bit complicated, but we practice now. For solving linear system of equation, by the way, linear system of equation is two equations separated by curly bracket like that. So basically is look, x plus ay equal 15. We have one equation. I like so much to put a number. Number one equation is, and the second is minus 2x plus 7y equals 16. Okay, so when you solve a linear system of equation, we have three possibilities. You have three possibilities. You need to be aware three possibilities. One possibility is that we have one solution, que is the most popular case. 99% of the time, it's only one solution, because the interpretation, remember, the interpretation is, so you are doing graphically. This equation maybe is one line, and maybe it's another line, and the common point is the solution, one solution. However, you need to be aware that we have another possibility. Another possibility is when the lines are parallel. You know very well when the lines are parallel, it's because have the same slope and never meet. They are no common point, therefore it's no solution. And finally, another possibility in which the line is the same. Wow, the same line. At the beginning, you don't know very well because something is confusing, but when you analyze in detail, it's the same line. So in this case, we have infinity many solutions. But how do you know this situation algebraically? It's the thing I want to study now. You need to be aware for this situation. 99% of the time, it's one solution. And 1% of the time, is this. Entonces, now, this is the graphic. Entonces, you say, bueno, professor, you say, okay, any problem, we need to do the graphic of the line? No. We are doing algebraically. Because I want to explain now how you detecting no solution, one solution, or infinity many solutions, right? Okay, algebraically, no graphically. This is the interpretation to explain the idea. We can do that, of course. We put in decimals, the equation. This is double checking, no? And you see the solution. Okay, so now basically in this part we study substitution. It's the technical name of this, substitution. You have two methods algebraically. Substitution. Substitutions. Okay, substitution is fantastic. It's easy to understand. However, substitution is useful only when the one coefficient of in front of the variable is 1 or -1. For example, in this example, you can see that coefficient is 1. Nice. So I take advantage of this. Si the coefficient is no 1, it's 8, negative 2, 7, and suppose that this is 10, those are not good substitution. Substitution is complicated. And we study another way to do this. But okay, we practice substitution now. I immediately detecting, wow, good. Coefficient in the first equation in front the x is 1. So I take advantage of this. I take the equation, I rewrite again here, because it's important for me, because the coefficient is 1, and you isolate that variable. So x is equal 15 minus ay. So you solve for x. You solve for the variable que contain coefficients 1 or negative 1. Now, important moment now. This expression, you replace substitution, que is the name for the x in the another equation. Here. Now you write minus 2 parentheses. Important this parenthesis, because this minus 2 multiply x. X is 2 binomial here. 15 minus ay plus 7y equals 16. And so in that moment, we have a new equation. No new, it's the same, but it's equation que contain only one variable, que es y. And also it's easy. It's very, very similar to the thing we are doing at the beginning of this semester. A multiplication is minus 30. Apply this trivial property. Plus 16 minus time minus is positive. Okay, and the rest is piece okay. The rest is combined like term. We combine. Okay, this is minus 30. This is minus 30. We combine 16 and 7 is 23, no? 23y equals 16, no? And you solve for y, those are 23y is equal 16 plus 30. 16 plus 30 is 46. So far we have 23y is equal to 46 divided by 23 both sides. Es obvio que es 2. Y is 2. And we feel no, because we need to find the ordered pair, x, y. You need to find two components, x and y. I have in my hand y. I need to find y. Substitution in either equation. However, in my opinion, the super fantastic easy way is using this equation because x is isolated, waiting for me to determine the value. Okay, 15 minus 8 times 2. You replace y for 2. Now multiplication, order of operation. Be careful with the order. You need to respect pendas. Okay, multiplication first. The 15 minus 16, it's negative 1. So what is the answer? The answer is the ordered pair. Final answer. Negative 1, 2. Bam, like option B. Any question? Substitution. Si you see que no coefficient is 1 or negative 1, avoid substitution. I explain another way. We practice 21, 22, 23, get substitution. Any question? Do you remember very well this or no? Of course, you need practice. But to get practice, the fantastic way is doing the homework online, Alex, okay? Okay, let's do number 21. 21 is x plus 5y equal 40. This is my first equation. And 2x plus 6y equal 48. This is my second equation. And together it's a system. So now suppose again I need to do by substitution. So I detecting in the equation 1 coefficient is 1. I copy, I solve for x 40 minus 5y and substitution this expression where another equation here. So we have 2 parentheses 40 minus 5y plus 6y equal 48. Everyone follow me or no?
Yes.
Yes.
Yeah. Now distributive. 80 minus 10y plus 6y equal 48. Ready to combine later. Minus 10 plus 6 is negative 4. Okay, minus 4y then is equal 48 minus 80. 32. Negative 4y, subtracting here, is 32 positive. Divided by negative 4 both sides. Y alone is equal negative 8. Now substitution here is obvious one. It's the best way, no? You can use either equation, guys. This is the beauty of this. The equation original 1, the equation original 2, and this doesn't change the answer. However, I take advantage of the work I'm doing before, because isolate x. X is equal 40 minus 5 times minus 8. So now multiplication 40 plus negative and negative together is 40. The answer is 80. No? Now the point is x equal 80 and the solution is 80 comma minus 8. No? Let me see if I did well. No? I did something wrong. Now let me see what is the problem. Okay. Oh, no. 48 minus 80. Yeah, look at that. Okay, mistake I make. It's minus 32. Because 48 is positive. Minus 80 is negative. Of course, you're subtracting. It's 32, but you put the sign of the bigger number, right? Entonces negative divided by negative es positive. Boom. Si es positive, boom. Entonces es no positive 40, es negative 40. And the answer is 0. Subtracting 40 minus 40 is 0. 0. 0. Therefore, the solution is 0, positive. Let me check it now. Yeah, it's B. B option. Cool. This is the dramatic situation for the mathematics. You make a stupid mistake in one detail and screw up everything. Everything changed, it's wrong. So be careful with the operation, no? The sign is tricky, you know. Okay, everyone follow me? Everyone understand very well this example? It's easy substitution? I suppose yes, right? It's easy. Of course, we need practice. And the only practice you need to do by yourself, not by look at me. Entonces now the fantastic way I create was the homework en Alex, no? And pretest. And when you are working hard in the homework and the pretest, you are ready to take the test online. Okay, 22. X plus 6y equal minus 3, equation 1. I like to call name. This is a number, it's a name. 3x plus 7y equal negative 9. Equation 2, this is my system. and you detecting here coefficient 1. Yes, sir. You take one more time, not necessarily always the first equation, and you isolate this. X is equal minus 3 minus 6y. And you take this expression and substitution here. Another equation, equation 2. So if you take the equation 1 and isolate the variable in the equation 1, so now this expression you substitution in the equation 2, another equation. So we have so far 3 parentheses minus 3 minus 6y plus 7y equal minus 9. Okay, again distributing minus 9 minus 18, 18y plus 7y equal negative 9. Okay, we combine to say is negative 18 and positive 7 is negative 11 equal negative 9. When you try to move this 9 to the other side, we have minus 11y equal minus 9 plus 9 is 0. Wow. When you divide by negative 11, it's obvious. Okay, why is it? Oh, see, it's nice. It's easy number to manipulate. Now, when you come back here, x is equal minus 3 minus 6 times 0. And 6 times 0 is 0. Therefore, x is minus 3. And the solution is the point negative 3,0. Negative 3,0 is the option 8. Is the option 8. Cool. Everyone follow me?
Yes.
Yeah, this is the easy problem. No? I promise. In your moment, you see very complicated problem. No? But I try to explain step by step. We start for the easy one first, and after we are doing the complicated. So don't expect everything is nice. No. You need to be aware for solving any system. For example, 23 is 5x plus y equal 45, equation 1. And 5x equal to y. Wow, it's a weird equation. It's a weird equation. However, I don't care. I do a similar. You detecting the variable, okay, have coefficient 1. So I copy 5x plus y equal 45. Therefore, y alone is 45 minus 5x. Okay? And you substitution. This expression where? Here, I suppose. Okay, so and another equation, no? So we have 5x equal 2 times 45 minus 5x. This is 5x equal 90, 45 times 2 minus 10x. My goal is solve for x. So I move is 5x plus 10x equal 90. This is 15x equal 90 divided by 15 both sides. I suppose it's 6, no? Just in case, let me check in the calculator. 80 divided by 15. Yeah, it's 6. X is 6, plugging in here. 45 minus 5 times 6 is 30. 45 minus 30 is 15. So x is equal to 15. Y is equal to 6, and the solution is 15,6. 15,6, option A again. No. Wait. Sorry, this is Y. I make a mistake again. Look, this is X value. So normally in the other example, and this is the Y. So this is the only mistake I call incorrect. This is Y. And the solution is 6,15. Don't forget, we just press it like order pairs solution. The first component always is x, and the second component is always y. This is the agreement, and you need to respect that. Cool? Anyone follow me? Follow me or no?
Yes.
This is easy. Do you remember very well in the high school, no? I know that this is good class. You prove me that you are good in the first test. And the diagnostic test, I disappointing a little bit. However, in the test, you improve a lot of. The majority of you improve. Okay. Let's continue doing substitution. 24, 25, 26, 27, 28, 29. Okay. I want to copy 24. Is y equal? Let me try. Y equal 5x. No. I make a mistake. Y minus 5x equal 8. This is my first equation. And my second is 5y minus x equal 4. Okay, cool. Remember the idea, the classical idea for elimination is you try to see what variable contains coefficient 1 or -1. And this is clear. This is -1. And you isolate this. But you don't isolate negative x. You isolate positive x. So I just copy 5y minus x equal 4. And my goal is isolate positive x. Well, one fantastic way, you bring down 5y, subtracting 4, moving 4 to the left, and moving x to the right. And this is expression. Okay, I substitute, put in the x. Another equation here, over there. Be careful with the sign, guys. 5y minus, I copy this minus, and x. This is binomial. This is binomial mandatory. You put the parentheses. 5y minus 4 equal 4. Okay, that 4 is that 4. Okay, so now you distributed this -1 can affect everything. It's 5y minus 5y plus 4 equal 4. Oh, something weird happened in this problem. The variable cancel out, disappears, and you get 4 equal 4. And by the way, it's true statement. And don't forget, remember we have 3 possibilities of solution of the system. One possibility is, one solution is the scenario that we are doing so far. But we discover now a weird. When you're solving algebraically, you are doing your best, no mistake, and you cannot solve for y or solve for x. This case was impossible because cancel out here. And you get true statement, it's because it's the case of the infinity many solution. Okay, infinity many solution, or another way to call this situation is all order pairs. Let me explain in detail. It's infinity. It's infinity. What means infinity? Infinity is all the xy plane? No. It's all the xy plane point? No. It's the point on this line 1. Okay, by the way, we discover that the line 1 and the line 2 is identical. I want to prove now. So the situation we discovered was that the line is the same. The equation 1 and the equation 2 represent the same line. Therefore, we have infinity many solutions, but on this line, no here. This point no is on both lines. Let me prove first of all to you know, to feel more comfortable, okay, this line is the same. So this technical name is they are dependent equation. For example, you take the equation number 1 and you solve for y. This is a plus 5x. And you move 5x negative to the right hand side positive. Okay, cool. And now let's do exactly the same in the equation 2. In the equation 2, you solve for y. Ooh, it's weird. All right. Okay, 5y minus x equals 4. Something is weird here. Hello. Again mistake. Okay. Again mistake. Mistake. I'm crazy. You take this equation. Okay, it's the equation that contains coefficient -1, and you solve for x. I did well that part. I copy. Now is 5y minus 4 equals x. But now use substitution. No, in the same equation. No. In the another equation here. So in another equation is y minus 5 parentheses 5y minus 4 equal 8. So you substitution in the same equation exactly. I did. I don't know why. I did because I suppose you always with substitution in the second. But no. Entonces now, of course, you get the identity. Yes, no. But no, in this case, no. Entonces y minus 25y plus 20 equal 8. Okay, we combine like term. Positive 1 and minus 25 minus 24y plus 20 equal 8. So for y, so you for example, you move minus 24y is equal 8 minus 20. Es 12, es obvio, no? Es 12. Es minus 24y is equal minus 12, subtracting, you put the sign of the bigger number. And finally, divided by minus 24 both sides. And y alone is 1/2. Okay, negative divided by negative is positive, and 12 over 24, obviously, so you divide by 12 top and bottom, and reduce it in lowest term, you get 1/2. Oh no, entonces no infinity many solution, it's unique solution. Now, in order to find the x value, again, substitution here. Okay, entonces 5 multiplication by 1/2 minus 4 equal x. It's a 5 over 2 minus 4 equal x. Okay, now again, the same dilemma okay, some students have, how we combine this. Well, you find the LCD. The LCD is so big as 2 because 4 is a whole number. Yeah, I suppose that 4 over 1 is the LCD between 2 and 1 is 2. And 2, this is 5 because it's identical. But this is no 4, it's 8. And where come from this 8 is 2 divided by 1 is 2, 2 times 4 is 8. And the answer is minus 3 over 2. Que es the x value. Okay, entonces the solution is minus 3/2, comma, positive half. Let me check it out. Is the option A, obviously. Guy, be careful. I make a stupid mistake. You isolate one variable and the equation que contain coefficients 1 or -1, and use substitution in another. So use substitution in the same, because everything is cancelled. And you believe que es infinitely many solutions. Exactly like that. Wow. Okay, 25. Do you follow me? Do you understand the idea?
I had a question. For this one, you had to put it into the first equation. How do I know if I have to put it into the first or the second? Because before you were just putting it into the second equation.
Good question. Miss, you take the second first. Yes or no? You take the second equation. Why you take the second equation? Because I take advantage of this coefficient is 1. Right?
Mm-hmm.
And you isolate x in the second equation. Now, the substitution part, see, I take at the beginning the second equation, you substitute in the first equation, que es another equation. This is the key word, another equation, okay? It doesn't matter, the majority of the example that we're doing before, you select the first and substitute in the second. In this case, was different. You select the second because coefficient here is -1, and when you isolate the variable associated with this, you substitution in the first. Make sense?
So we always try to isolate first x.
Yeah. Okay. Repetition again. The big idea, the central idea for the substitution is you detecting in one equation the coefficients in one variable is 1 or -1. In our specific example, I can see the coefficients in the equation 2 is -1 here, right? So you take advantage of this fact and you isolate that variable, but by using the equation 2. Therefore, when you substitution this x, you plug it into the equation 1 because the equation 1 is another equation. Makes sense now?
Yes, but I have a question. Here the y also have 1 in the first equation.
Yes, you're right. It's another possibility.
Yeah, so I can start with y?
Yeah. Do you want
okay.
for you? Do you want I do for you?
I understand, but if somebody else wanted.
Okay, good. Good for you. Good for you. In my opinion, I don't see that, but in my opinion, it's better. It's better using it. So in the equation 1, y is isolated. You isolate the y and substitution this expression, new expression, in the equation 2. For sure, this is the beauty of the mathematical. So you are doing well. It doesn't matter the way you apply it, you get the same answer. Cool?
Yes.
Cool. Okay, so now, maybe I don't see very well. Now you help me. You help me to see more clear. You help me to see more clear now. Okay, I want to copy, well, no, erase. I want to copy the next example. Okay, the next example is, okay, the next example is 25, no? 25. The next example is 2x plus 11y equal 1, equation number 1, and 2x again, repetition, minus y equal 14. Okay, so you help me now, because sometimes I don't see detail. What you consider is the variable that have coefficients 1 or -1? What variable and in which equation?
Y in the second equation.
Super. You are expert. You say better than me. Y in the second equation. So you take 2x minus y. Just copy. I bring down. I do my best to isolate the y. Maybe the fast way is you move to the right hand side and 14 to the left. And now ready. This expression substitution where? Okay, substitution where. See, I take the second equation, obviously use substitution y here in the first equation. So don't do it like me and the other, in the first, very, very well. 2x plus 11 parentheses, it's important this parenthesis, because this 11 multiply y, and who is y now? 2x minus 14. Entonces, 11 2x minus 14 equal 1. Do you see the change? Okay, did that? Oh no. Okay, now distributing. Multiplication. 2x plus 22, because 11 times 2, and 14 times 11, I put it in the calculator, of course. 11 times 14 is 154. So minus 154 equal 1. Cool. Now you combine 2 and 22 is 24. And why not move 154 negative to the other side like a 1 plus 154, no? Que es 155. 24x is equal 155 divided by 24, both sides. X is equal 155 divided by 24. This is the x value. In this case, no, we cannot reduce the lowest term because 155 is only divisible by 5 and 24 no. They leave it like that. Now I try to find the y value. So substitution, this weird number here. Be careful with the order of operation. You multiply 2 times 155 over 24 minus 14. Okay, order of operation, multiplication first. You multiply 2 times this, it's obvious that you will cancel out this, divided by 2, 1, divided by 2, 12. So my computation is a little bit more clear. 155 divided by 12, okay, minus 14. Least common denominator is 12. Obviously, this is the same number because it's the same denominator, but this no. This is 12 times 14. Okay, it's 168. And now subtraction, 168 minus 155 is 13, but it's negative 13. Negative 13 over 12. Guys, everyone can use a calculator. Don't be scared. I don't care the arithmetic part. The arithmetic part is irrelevant. This is algebra 1. So the arithmetic, I suppose you know. So this is the y value. Now the solution is 155 over 24, comma, minus 13 over 12. They correspond with the option B. I guess so. Cool. Everyone follow me? No answer.
Yes.
Yes, I got it.
Okay. Okay, 26. I want to copy. Okay. 26 say minus 7x minus 19 equal minus 6y. 2x plus 4y equal 46. And this example, this is the typical example in which it's not good apply substitution because no coefficient is 1 or negative 1. Coefficient in front of the variable are negative 7, negative 6 and y, 2 and x, and 4 and y. No 1. This is not good for substitution. However, they want, we are doing by substitution, so I need to obey that order, that command. Okay, so you decide what equation you consider easy. Okay, one fantastic way, guys, is express it. First of all, you express it in the equation in standard. What is that? This is minus 7x. I move 6y equal 19. So I move, the motion was this negative 6y, I move to the left, and 19 I move to the right. And the second equation now is 2x plus 4y. This is already in standard. I don't need to change 46 equation 2. Okay, so more clear. At least this is disorganized. Now both equations are in standard. So I need to make decision. And my intuition is, well, you take the equation number 2. Why? Because I consider it easier, a little bit. No, not too much, but it's easy. And you isolate, for example, that part. So you decide isolate the other part, it's okay. So now I take 2x plus 4y equal 46. Now 2x is equal 46 minus 4y divided by 2, divided by 2, and divided by 2. And x alone is 23, I guess. So 46 divided by 2 is 20. Yes, so we get 23 minus 2y. And now you take this expression and substitution where? Why not another equation, but what? And the x place here. Right? Okay. So 23 no. Minus 7, parentheses, minus 7, parentheses, don't forget never the parentheses, 23 minus 2y plus 6y equal 19. And now distribute it. Well, 23 times 7 is 169. Negative 161 minus no plus, negative times negative positive 14 y plus 6y equal 90. We combine 161 plus 20 y 14 plus 6 equal 90. Therefore 20y is equal 19 plus 161. 161 plus 19 is 180. Wow. 180. And divided by 20, I suppose que 9. Okay, because this 0 cancel out, and 18 divided by 29. Wow, nice. We manipulate weird number, however, it was nice answer. Now, substitution this 9 here, x is equal to 23 minus 2 times 9 is 23 minus 18 because 2 times 9 is 18 because subtraction is 5. Solution then is 5, 9, like it all appears. Okay. What is that? We are doing 5,9. Option A. Okay, so we face in this problem one problem, in my opinion, you know, I respect any opinion. Never we are doing by substitution. We are doing by another way I want to explain in your moment. Okay, but I obey the command. Substitution you want, substitution I do. Okay. 20, 20, 20, 27. One more of substitution. Oh, no, one more no. No, we are doing completely, yeah. Because this package is good. This package has every possibility you need to know. Okay, cool. 27 is 3x plus 4y equal 5. This is my first equation. And my second equation is 9x equal 10 plus 12y. Okay, and this is my second equation. No coefficient 1, and the second equation is totally disorganized. More elegant would be 3x plus 4y equal 5, equation 1, and 9x minus 12y equal 10, equation 2. This is already expressed in standard. Remember, standard is equation like that. Ax plus by equals 0. Okay, in alphabetic order, x first, y secondly, and in the right hand side just the number c, que es 5 and 10. Okay, entonces I am totally lost. I have no idea. Substitution. Wow. Let's do it. I suppose that the easier equation, in my opinion, is the first one. 3x plus 4y equal 5. And you isolate x or you isolate y. Either way. Suppose que I isolate y. So 4y is equal 5 minus 3x. Divided by 4, divided by 4, divided by 4. So far, y alone is 5 over 4 minus 3 over 4x. Wow, fraction. I don't like fraction. It's okay. That is the reason que in the next topic we study another way to avoid the fractions. So now I plug in where? Plugging in, I using the equation 1, no? This is equation 1. Now I substitution this in the equation 2. I suppose, no? Here. Okay, nice. Entonces es 9x minus 12, paréntesis, 5 over 4 minus 3 over 4, x equal 10. Okay, the only thing I did was replace y for this expression, that is 5 over 4 minus 3 over 4. And some students say, well, professor, you can do it in that way, or when you divide by 4, you copy 5 minus 3x over 4. Either way, this is okay. So this 4 is common denominator, and you condense in only one. It's okay. It's okay. Now, ready to apply distributive. In this case, super easy because 12 is divisible by 4 gets 3. So you divide 12 divided by 4 gets 3 times 5, 50. 50 plus negative, double negative become positive. And this is 12 divided by 4 is 3, 3 times 3 is 9. X equal 10. Do you see this multiplication? So 12 times, or negative 12, sorry, times 5 over 4. Time. Anyway, you can divide first and multiplication secondly. The order of the operation is completely irrelevant in this case. 12 divided by 4 is 3. So you reduce mentally, minus 3 times 5 is negative 15. Okay, and likewise, minus 12 times minus 3 over 4, okay, is 12 divided by 4 is 3. So actually it's 3, pero double negative become positive, 3 times 3. And now, and 9 plus 9 is 18. We combine later, 18x is equal 10 plus 15, que es 25. Divided by 18 both sides. X is equal to 25 over 18. Wow, it's weird. Let me check and see if it makes sense or not, this answer. Oh yes, look at that. 25 over x value, no? 25 over 18. Okay, cool. We're doing well. Okay, so now I need to find the y value. Substitution, that value, in this expression, obviously, right? Because y is equal 5 over 4 minus 3/4 multiplication by 25/18. Wow, it's crazy. Okay, no big deal. This is remember multiplication first. 3/4 times 25/18. And it's obvious it's 75. So you multiply top, bottom, 18 times 4 is 72. Oh, much better. Because you can reduce a little bit in lower study divided by 3. So you can, to make easier, you divide 3 divided by 3 is 1, and 18 divided by 3 is 6. And now multiplication, 1 times 25 25, and 4 times 6 is 24. It's exactly the same answer when you divide it by 3 here. By 3, no. By 3, yeah. By 3. And 72 divided by 3, no? It's 24, yeah, by 3. Guess the factor. Okay, eliminate that part. So actually, it's 5/4 minus 25/24. It's obvious that the LCD is 24. And 24 divided by 4 is 6 times 5, 30. Minus, and this is the same because it's the same denominator. 30 minus 25/5/24. Okay, in this case, we cannot reduce in lower term. The final answer is x is 25/18, comma 5/24. Okay, the option, let me see what option is the good. Okay, the option B. Option B. Okay. It's no big deal. The only complication in this problem is the fractions. But I recommend using calculators. One fantastic calculator everyone needs to have from now to the next mathematics and this mathematics is the calculator TI Texas Instrument 38. And this allows working with the fraction and to avoid this situation. At any moment you have, when the student, you have that, go to the lab in person with me Friday. Yeah, I can teach how we working with this in fraction. Do you follow me or no? Confusing part in the fraction?
Yes, I follow.
Yeah. Got it. Karen Diaz. Okay, Karen. The two next problem is very, very important because it's the classical idea when you have infinity many solution or no solution. Let me try. 28 and 29. 28 and 29. Okay, 28 say x plus 4, x plus y, sorry, equal 4, equation 1, and 3x plus 3y equal 12, equation 2. At the beginning, I have no idea. Surprise, no? After I want to explain intuition, but no, suppose I don't know. I don't see anything. I suppose it's this regular problem. We have one solution. You try to say you, for example, make a decision. Remember, there are no infinity, but there are many ways to solving that problem. You take the equation that you consider easier, in my opinion, is number 1. And you isolate one variable, I don't know, see x or y. Some students isolate x, another student isolate y, but you get the same result, no problem. Suppose that you take the first one and you isolate x. I don't know why. There are no special reason. And you now substitution this. expression and another equation in the x place because it's x, no? And you copy. 3 parentheses, don't forget the parentheses. 4 minus y plus 3y equal to 1. And you apply distributive. 12 minus 3y plus 3y equal to 12. And suddenly we are happy. The variable disappears. It's cancelled out. And you get 12 equal to 2. And you need to interpretation this. This is true statement, of course. So you cannot solve it. And the reason is because it's the same line. Therefore, the solution is infinity many solution. Okay, but the thing I try to explain. Look. Okay. I detecting with this idea that this equation and this equation is the same equation. Okay, one possibility to understand is you take, for example, this equation and you solve for y. Okay, it's 4 minus x. Okay, and leave it like that for the moment. And you take the second equation, that's 3x plus 3y equal to 12. And you solve for y again to compare. The 3y is equal to 12 minus 3x and divided by 3. Divided by 3. Divided by 3 because my goal is solve for y. And 12 divided by 3 is 4. And minus 3 divided by positive 3 is negative 1, which is 6. And you see, wow, fantastic. This equation is exactly the same of this. This equation is the same line. Therefore, so you are doing the graphic representation, this idea, suppose that this is one line, equation 1, and this is the same line, equation 2. That is a reason that we have any point on this line is solution, no out, in. So what is the correct way to do this? You open the curly bracket and you put all real number, or much better, all order pairs, no x, x comma y, such that every order pair such that satisfy this equation and this equation, and you copy the equation 1 or the equation 2 or this equation in which you isolate the y. Okay, you compare as the same. In this case, they copy the equation 1 because I know very well okay, they are completely equal. The technical name of this equation are dependent. And this equation are dependent means it's the same line. If you, for example, another way to see that, you take the equation 1 and you multiply the entire equation 1 by 3. 3 times x, 3x. 3 times y, 3y. 3 times 4, 12. And you get the equation 2. Okay? So if you take a line equation and you multiply by any number, you don't change the line. It's the same line. They are dependent line, dependent equation, and we have infinity many solutions. And the way to represent this is all real number. There are many ways. In my opinion, the correct way is C. All order pair along x plus y equal 4. So you put, for example, all order pair along 3x plus 3y equal to, it's the same thing. Of course, more elegant simplification, but this is okay. Or all order pairs such that y is equal 4 minus x like this. It's the same, okay? But the important is that it's all infinity many solutions. Okay, clear? Oh no.
Okay.
Let's move on to the 29, que es special also, but different. Look, in the 29, I can see, wow, something is weird because x plus y is equal -4, equation 1, and x plus y again, by the way, is the same expression, x plus y equal -2. Do you see que es a contradiction? Using intuition, without algebra, no algebra, one expression equal 4, -4, and the same expression is equal -2. This is impossible, impossible, right? However, suppose that I don't see clear, okay? So I try, you take the equation that you consider easier, in my opinion is the second one, and you solve for x or for y, solve for y. X equal -2 minus 6, and substitution, this expression here, in another case, this here, the y place. So I copy, x plus something, and this is y, and y is -2 minus 6, should be -4. In this case, not necessary parentheses, because the coefficient here is -1, +1, sorry. And then you remove. Okay, so this one, okay, let's do it on the parentheses, because actually in the second line I write x -2 minus 6 equal -4. The thing is, I believe that this is +1, and +1 times -2 is -2, and +1 times -x is -x. And again, happen that this is cancelled, but you get completely false statement. Interpretation this, no solution, because these lines are parallel. Same slope, but never meet. No common point, no solution. Super clear? Super clear?
Yes.
Yes.
Excellent. Now we start elimination method. Let me explain in detail elimination. Elimination, in my opinion, is the best way. Substitution, Claudia. Substitution, you apply substitution only when coefficient is 1 or -1. Otherwise, no. Avoid substitution. Here I go to elimination. What is the key idea for elimination? Elimination is, suppose I copy this problem. X plus 5y equal 32. Equation 1. 6x plus 5y equal 67, no? Yeah. Equation 2. This is my system. You solve it, and nobody say, well, in this case, yes, elimination. But suppose in the real life, nobody suggests you substitution or elimination. No. So, well, you can do it by substitution because coefficient here is 1, but no. I respect this command, elimination. And what is the key idea for elimination? The key idea is you need to the same coefficient. For example, 5y. It's the same number, but you need opposite sign. One is positive and another is negative. And when you adding this equation, cancel out and you get 0. This is the idea behind elimination. But you need to enforce that situation, not always say happy. Now, one possibility is, look, you multiply the equation 1 by -1. And you know very well that when you multiply any entire equation by a number, doesn't matter what number, positive 1, -1, 20, 40, doesn't change the line. It's the same equation. They are dependent, equivalent, but it's important because when you multiply by -1, it's a -x. And doing the multiplication, -1 times x, -1 times 5. -1 times 32 is -5y equal -32. And guys, for sure, I guarantee you 100% that this is equivalent to the original equation 1. Now my problem is reduce it, no, and this, you know, in this equation. And now it is ready for elimination method. Why? Because the key idea, look, was you have same but the opposite sign. When you adding this equation, you adding equation 1 plus equation 2, but you adding a special way by column. 6, like that. 6 minus 1 is 5. This and this say goodbye. S0. Elimination. This idea. And 67 minus 32. Let me put in the calculator. 67 minus 32 is 35. Positive. And divided by 5 both sides. X is 7. Cool. I like that. I think, no, of course, no. I need to solve for y. But to do this job, I decide what equation you consider better. In my opinion, I using the first one equation, but no, the new ones. You know, this is the one new, and this is one original or old. Now using the old because in my opinion it's easy because it's positive sign. So you replace 7 here. It's 7 plus 5y equals 32. Okay, you replace x is 7, I know. Entonces okay, 5y is equal to 32 minus 7, que es 25. Divided by 5, both sides. 5 is what? F5. And the solution is the order pair 7,5. Okay, we are doing the first problem of the elimination. Option A. Cool, very cool. Elimination is cool. In my opinion, fantastic. My recommendation, my recommendation is when you solve in the system, the majority of the solution you are doing using elimination. Well, see, at least one equation, the coefficient is 1 or negative 1, you can apply substitution. So in the test guide, you are free to select the way that you consider. Okay, the important for me is the final answer. Okay, so my recommendation is elimination, the majority of the time. And sometimes it's easier substitution. Okay, let me try next page. Next page is this, I guess, no? Yeah. Okay, you help me to create the strategy for solving the equation. X minus 4y equal 11, equation 1. 2x minus 4y equal 14, equation 2. This is my system, it's given like that at the beginning. Here I need to solve it using elimination. Okay, let's do it. What do you recommend me to do? Remember the key idea for elimination. Elimination is we need the same coefficients. Like you take advantage. Go ahead.
Like the easiest equation to transform it to the opposite sign. By multiplying by.
Which one? Number 1, number 2?
Number 1.
Beautiful. Multiply by negative 1, right? Very well. This is the idea. Similar. You multiply by negative 1, this equation, multiplication by negative 1, and you obtain minus x plus 4y equal minus 11. And this is my new equation 1. Now, I change the system like that. Okay, now 2 minus 1x is ready for elimination. And 14 minus 11 is 3, right? Wow, easy. 3 comma something. Now, if you want to solve for y, you take either equation. Of course, I am smart. I take the easier equation. Substitution 3 here. So 3 minus 4y equal that. I substitution that 3 here. Minus 4y is equal 11 plus. No, plus no, minus 3. Because 3 is positive, when I move to the side negative, because it's minus 3. Entonces negative 4y is equal 8. Divided by negative 4 is negative 2. This is the y value. Entonces la solución es 3, negative 2. Like this. Do you see it's easy elimination, guys?
Yes.
Yeah. Who is this boy? Your boy? Your child?
No, my little brother.
Oh, okay. Okay, 30, 30, 32. 32. It's the last one that we are doing today. This is the beauty of the class online, no? Participate the family. Okay, x minus 2y equal 13. Equation 1. 9x minus 3y equal 57. Equation 2. What should I do? Tell me. Well, this get a little bit complicated, no? Well, no. You multiply by negative 9, no? Maybe. Remember the key idea for elimination. You need to guarantee, using multiplications, the same number with the opposite sign. So there are many ways. One way is you multiply the first equation by negative 9. Cool. It's a one possibility. Or another two say, no, I don't like this. I like multiplication, the equation 1 by 3. And when you multiply by 3, 3 times 2 is 6. And you multiply the equation 2 by negative 3. And you eliminate the y. What do you consider is the better way?
Minus 9.
Minus 9. I agree with you. So she said it's better multiplication negative 9. This equation to say we have negative 9x. This is negative 9. No? This is positive 18y. Because negative 9 and negative 2 together, multiplication, and 13 times 9 is 100. Wow. Is negative 170. Okay, I multiply by 9. And this is my new equation 1. It's exactly the same, but I using this system, not the original, but this is ready for elimination. This is ready for elimination. Elimination, the x part. Entonces 18 minus 3 is 15. Positive. And 117 negative. Minus 57, subtraction is 60. That is negative, right? Divided by 15 both sides is 4, no? And negative 4, yeah. Yeah, and negative 4. And this is the y value. To find the x value, well, you take the easier equation, in my opinion, is the first one. And so you replace it, x minus 2 times negative 4, because y, I know, okay, negative 4 is equal to 13. And negative 2 and negative 4 together is positive 8. So it's x plus 8 is equal to 13. X is equal to 13 minus 8, que 5. And the solution is 5, negative 4. 5 comma negative 4, 5 comma negative 4, 5 comma negative 4, 5 comma negative 4 is the option A. Cool. Very good. So Friday we continue, right? Friday we continue that part and the last part. And maybe we have time to continue review Monday. But Monday is the due day. But Friday I will send the test on paper. Guys, sorry. This is too intensive because it's 8 weeks. So we never stop. Okay? So what is the idea? I try to do your best always. Friday, I will send the test. I suppose that you are doing now homework, pre-test, que es no mandatorio, pero so you want to practice, no? Online. And taking the test online 2 times. Take the best score. And the test on paper. And don't forget, send me the solution for the test on paper by the student email of the Miami-Dade College, right? No your own private email, because I don't know why the cybersecurity of the Miami-Dade is very, very picky. Send me to junk email. Yeah, I never see this. Well, I see, but I need to find. No. Okay, guys, entonces now, super good, super good. I enjoy teaching you. I have another class now. Bye-bye. Soon I will send the video, okay?
Okay, bye, Professor.